So let's do one more example to really try to think through everything about angular velocity and linear velocity and some of the connections between those things. So again, we're going to talk about a turntable, right? So we've got some kind of turntable. And I'm actually going to think about that turntable being turned off, but it's going to get turned on. And there are actually two things I'm interested in. I've got a bug that's located halfway out from the origin, and then a bug that's located all the way out from the origin. Okay. And I'm going to ask the question, when I turn on the turntable, and as the turntable speeds up, what happens to the acceleration of these bugs? What happens to the angular acceleration of the bugs? What happens to the velocity of the bugs? And what happens to the angular velocity of the bugs? Okay. So let's actually think about, first of all, the velocity, because that might be the easiest for us to think about. Pretty clearly at time equals 0, both of the bugs have 0 velocity. Right? So if I think about bug 1 and bug 2, right? Time equals 0, both of them have 0 velocity, right? A little while later, both of them will have a small velocity that's down to the right, but you'll note that the velocity of the bug that's further out will be larger than the velocity of the bug that's closer in. The closer you get to the origin, the slower the bug is actually moving. So a little while later, if this is bug number 2 and this is bug number 1, bug number 1 will have a small velocity, bug number 2 will have a velocity that's actually twice the size of the velocity of the first bug, since it's twice as far from the origin, right? A little while later, bug number 1 will have a bigger velocity and it'll be down, right? And bug number 2 will also have a bigger velocity, it'll be down. Again, it'll be twice as big as the whole velocity and so on, right? Okay, so that's what my velocity looks like. What does my acceleration look like? Let's think about that. Well, two things are happening. One is that at any given instant, I am accelerating in a tangential direction, right? Because the turntable is speeding up. And the other thing is that's happening is that as the turntable speeds up, I'm also turning, right? So if I think about, say, this point, I should have an acceleration that is both forward and also an acceleration that is radial, that's inward, right? That's sort of a centripetal acceleration. So my net acceleration at this point ought to be something like that, and pretty clearly it will be larger for the outside bug than for the inside bug, because the velocity that's changing is larger, right? Here you're still going to have a forward acceleration and a radial acceleration, so it'll look like this, right? And so on. Okay, so you can see that the accelerations also are going to be different. If the size of the velocity that's changing is different, the accelerations that are changing are different. Finally, if I think about angular velocity, notice that whether I'm looking at this bug or looking at this bug, the angle theta that bug is at is actually going to be the same, right? And so as the turntable speeds up, right, both bug 1 and bug 2 have angular velocities that are coming out of the page, right? They're actually the same size, and as time goes on, they go from being 0 to being positive to being more positive. This is the example we already talked about. And finally, since the angular velocities of both bugs are the same, the angular accelerations of both bugs will be the same as well, right? And now I'm sort of confusing my directions here, but they will both be out of the page, right? And they'll start out being a positive value, and as time goes on, if the turntable then starts to spin at constant speed, they'll just be 0. Okay? So that's kind of a walkthrough of how angular velocity and angular acceleration for objects compare with the linear velocity and linear acceleration. They are not the same thing, as you can see. I mean, in this case, the linear acceleration is changing direction as time goes on and has different magnitudes for both the inner and the outer bug. Velocity is changing direction and has different magnitudes for the inner and outer bug. On the other hand, the angular velocity for this case is not changing direction. Angular acceleration is not changing direction. And the sizes of the angular velocity and angular acceleration for both objects are the same.